Hello, welcome back to the shop. This afternoon we're going to be making some shims for the old drill press. And I've got some math equations, that scares everybody, but math is kind of important. I believe it's God's way of explaining how things work, and we're just kind of allowed to discover little pieces of math as time progresses. But anyway, enough of that. Let's say you have two holes of somewhat equal diameter. Doesn't matter if it's in a 5-hole bolt pattern on a car. It doesn't matter if it's two holes but we just got two holes here, and we need to find the spacing between those two holes, the center spacing between those two holes. Well, it's pretty easy to take your caterpillars. I just got a pair of cheapo digital caterpillars here. Take your digital caterpillars, and you can always find the distance from the outside to the outside. That's pretty easy. Use this part of your caterpillars, and that's easy to measure. And so is the distance from the inside to the inside. Just like that. Well, that's all you really need to know, given if the two diameters are the same. So you have a measurement A and a measurement B. Okay, so we know that measurement A plus 1 diameter is going to be the spacing. Measurement B minus 1 diameter is also going to be the spacing from center to center. So if we subtract A from B, divide the answer by 2, that gives us our diameter. Or we could just directly measure the diameter and one or the other of these and do that math. But this is a good way to check. I usually do it both ways and then double check myself, because I do make math errors. So with my calipers, I've measured 3.363 thousandths on the outside of the hole spacing, 2.373 on the inside of the hole spacing, like so. I do the math, and I come up with 990 difference. Divide that by 2, and I get 495 diameter of my holes. And I double checked it, and that's every hole on this thing. This one's 497. This one's 498. This one's 497. This one's 497. You measure on the insides, and they're 490, 485. Anyway, that's close enough for the girls we go with. So to figure my hole spacing, I add one of those diameters to the small number, 2.868, subtract it from the big number, 2.868. So that shows me I'm pretty close. And I can take a direct measurement, just kind of hook right there, and then measure from the top of this hole to the top of this hole, and kind of eyeball the edge, and I get 2.87, shaking, 2.857, 871. I'm right in there. So I know I'm fairly close on those numbers. So I'm back over here at my Chicom drill press, and I've laid out for my hole spacing here. This is just regular old galvanized sheet metal. I believe it's 26 gauge. It's just ductwork sheet metal. I know a guy that builds a lot of ductwork, so I've got some of this laying around. And I've just kind of guessed at it, and did a little bit of ciphering, but mostly just guessed to figure out how much from the center of this hole is where my cut line needs to be. And I also, by looking at things, figured out I needed about a 1/2 inch radius right here to get all the way up underneath of the bearing cap. And I've also put some 1/2 inch relief holes here so that I've got a nice smooth radius in this corner, because I'm going to cut this out 10 snips, and it's hard to get a nice corner right here without any distortion. So I just drilled it, and there you go. I center punched all my holes, stepped it, I stepped everything off with a pair of dividers, laid it out on this. This is just cheap lacquer spray paint. Works great for marking paint or for Dykem. So does purple primer, by the way. But anyway, that's how I do my layout. Laid this out, center punched all my holes, and then just reached in here without clamping it down and just spotted on the drill press, just spotted in my holes on the center where I could eyeball it real good. And now I'm just drilling it with my little homemade pallet here. And anyway, I'm going to drill these. I'm going to pause this because I can't get to everything without blocking the camera. You get the point. Clamp her down with the clamp on the mini pallet, and bang, now you can drill, and it doesn't jump around. It's pretty important on this, if you're going to drill multiple layers of this thin sheet metal, to clamp it, and clamp it good, because it will grab the drill bit and slice you to the bone. Now, the way that I got a hold and did this, this was a scrap of sheet metal. It's 3 inches wide, give or take. And I just rolled it up in a roll about this big around and squished it flat and then stomped on it and then took a hammer and hammered it. And that gives me, I think there's 9 or 10 layers in here of sheet metal that I can drill all these holes exactly the same at once, and it's not going to move because it's all hammered flat. So I'll get these drilled, and then we'll start cutting things out. So here we are. This is my pattern piece. Now I'm going to cut this out very carefully, staying right on the line, and then I'm going to deburr it with a file. Now, having them all stacked up like that, I don't have a whole lot of flash and burrs on it. But since this is going to be the pattern, I do want to have it as burr-free as possible. Now, we're not holding anything to a tolerance of 1/10,000th or anything like this. Honestly, I've got a tolerance of like a quarter, or not a quarter, but a 16th, or at least 3/64ths of an inch. You can see these take a 7/16 bolt, which you don't see a whole lot of 7/16 bolts anymore, but these do take a 7/16 bolt, and you can see, there's room for error. So I'll, like I said, I'm just going to cut these out very carefully with a good pair of tin snips. These are Malco's. Not my favorite pair, but they are a good pair of tin snips. Give that a little relief there. And if you scribe your stuff pretty deep, your tin snips, when you're doing this kind of work, your tin snips will kind of just want to follow in the furrow. I know that's kind of a weird idea, but your tin snips will want to follow the plow line there. Boy, this is hard to do in front of a camera. There we go. Now I'll give that a little bit of cleanup, and I'll be back in just a mere matter of moments. So here we go, we're back. And I've lost my ink pen, here it is. And here's my pattern piece. It came out okay. That's about what I wanted. It looks awfully close to what the original shims came out looking like. But you can see, you know, it sits right up next to the edge of the Babbitt. I don't want them way over out here. I want them pretty close to the edge of the Babbitt. That way there's no way that this can get sidled around and get into the shaft. I want it, and the Babbitt doesn't bear anything anyway. It's all on the iron that's bearing on the bearing. Now this Babbitt has got some weird defects in it, but you know, it's probably, I would imagine this is the original Babbitt. I don't have any reason to suspect that it's ever been repoured. So if it's lasted 100 years, it'll last another 4 or 5 probably. So there's a shim, and here's how I do my tracing. I use a blue pen, courtesy of my bank. And when I do this, I use a pen instead of a Sharpie or something like that. Number one, because they give me pens at the bank for free. Well, not for free, but I get pens at the bank. And number two, it leaves a fine line. A Sharpie leaves, a brand new Sharpie leaves a 32nd or maybe a 1/16 of an inch thick line. And an ink pen leaves a much thinner line. So I can actually see where that line is. And if I scribed it, that would be an even better line, but I can't see the scribe, especially if I'm trying to record something. So there you go, that'll wrap it up for this little video. May get around to setting these Babbitts up this evening, may do it tomorrow, don't know. I need to get some stuff off my workbench. That's why I'm trying to get this drill press back together. Got more work coming up next week. So anyway, we'll talk to you later. Y'all have a good, safe trip. Watch for deer.